Hi everyone, this is Statistics, Unit 9.2, and we're going to be estimating a population mean. So you're going to go ahead and read through a lot of this that's being given. We're going to be looking at degrees of freedom here, and we need to be able to calculate degrees of freedom. I do have a note here at the top. It says, since we don't know the population standard deviation, then the next best thing is to use the sample standard deviation. And we can use that because if you recall, your sample should be a reflection or a good representation of what your population means as a whole. And also, if you remember, the smaller the sample, the greater your margin of error is going to be, and then vice versa, the greater your sample, the likelihood of your margin of error is going to be smaller. So we have degrees of freedom here. And again, I have some more notes down here at the bottom. But you're going to want to know that your degrees of freedom is df equals your sample minus 1. Again, your sample minus 1. So maybe it's a good idea to have that highlighted. And you're going to see a lot of these calculations that I'm going to kind of glance over, incorporate these calculations in some problems down below. But it says, note, the z-score tells you how many standard deviations from the mean a number is. And then the t-statistic represents the number of sample standard deviation errors. X bar is from the population mean, mu. Okay, now that might not mean much to you maybe in a word sentence, but if you look at it on a graph and you're showing the spread of data that we learned in prior units, it's taking those prior understandings of mu, standard deviation, variance, the spread of data along a normal distribution curve, and then applying it to this lesson where maybe we don't know certain terms or certain characteristics of the data that's being given, and so we have to find other ways to obtain data. So moving along here, as you can see, your degrees of freedom is df equals n minus 1 sample size, and we have what's called t-distributions, and we're going to have to find the t-distribution, and I will teach you how to do that. Very similar, kind of like z-score, if you recall. So here's some calculations again. T alpha over 2 is computed with df equals n minus 1. If you recall, ME is margin of error, and you're given a formula there. So clearly a lot of formulas. It might look very confusing in a very chaotic way, but as we go through examples, hopefully it will be simplified. So here's your degree of freedom, very similar to where this would have been like your z-score in table A before. So we have degrees of freedom, and then we have our t up at the top, and then you want to find it. So we'll have some practice here. So it says, suppose that the individual times it takes for a running team to run a mile is normally distributed with an unknown mean. That's one of the characteristics that we need for this to work out. An unknown standard deviation. The times of 11 runners are used to estimate the mean time of the team. What t-score should be used to find the 90% confidence interval for the population mean time? So of course I have this already pre-filled out to save time, and you guys seem to like to have pre-filled out notes. But my sample is 11, right? It says 11 runners, so that's the first thing you want to write down. Then my confidence level is 90%, so 0.90. You're going to want to write that down. And then to find my degree of freedom, I need my n minus 1. And if you recall, my sample was 11, so I get 11 minus 1 here. So my degrees of freedom is 10. Well, I need to find what my t is. Okay, I need to find what my t-score is. Well, to get that calculation and find it within the chart here, what I need to do is calculate my alpha first. To calculate your alpha, it is 1 minus your confidence level. So 1 minus 0.90, and I get 0.10. Once we do our alpha divided by 2, you'll get 0.05. So what I need to do is go into my table and find t 0.05 with a degree of freedom of 10. So my degree of freedom, maybe it'll be helpful if I highlight this, that way we can find it. And then degree of freedom is 10 right here. That way you can kind of track where we're finding everything. Degree of freedom is 10. Degree of freedom is 10. And then want to find where t is 0.05. That's right here. And you just kind of maybe draw an arrow for yourself. And there you have it. So what t-score should be used to find a 90% confidence interval for the population mean time is 1.812. 1.812. So that's how you do that. Very similar to z-score, except utilizing different information as well as different equations to, again, find your t-score. All right, let's try it again here. Suppose that test scores are normally distributed with an unknown mean. Again, that's important. And I have a feeling some of you are like, why is that important? Because we glanced over it, and that's why reading this at the top on your own is important. But it's right here. Population mean, mu, and population standard deviation are unknown. These are conditions that need to be met. Okay, again, conditions that need to be met for t distribution with degrees of freedom. So let's go back down. The scores of 22 students are used to estimate the mean score. What t-score, so we have to use the table again, should be used to find the 95% confidence interval for the population mean score? So right off the bat, you need to find your sample. The sample was 22. It gave us our confidence level or interval. It was 95%, so 0.95. Next step, I want to find my degrees of freedom. If you recall, your degrees of freedom was n minus 1. So I think that my minus sign is not very clear there. So I get a degree of freedom of 21. I'm going to highlight that. Well, next we need to find what our value is going to be in the t table, or I shouldn't say t table, but for our t distribution or t-score. And that is going to be alpha, which is 1 minus my confidence level, which I get 0.05. We can't stop there. Remember, we have to do our alpha divided by 2, which is 0.025. So that gives me a t 0.025. I'm going to highlight that because we need that in the table. So when I have my degree of freedom, and then I have t 0.025, I get a t-score of 2.080. Okay. All right, now we're going into some kind of longer problems here. They're not too difficult. It's just a lot of memorization and then utilizing what we just learned. So clearly there's a lot of information that's being given at the top, very similar to 8.1, 8.2, and 9.1. But it says, example, the commute times for the workers in a city are normally distributed with an unknown population mean and standard deviation. Again, if you recall, for this to work out, these are going to be unknown. If a random sample of 23 workers, let's highlight that because that's our sample, is taken and results in a sample mean of 22 minutes and a sample deviation of 2 minutes, find a 99% confidence interval estimate for the population mean. Well, let's write down everything that we have that's being given here. So we have our sample. It says a random sample of 23. We have a sample mean, x bar, that's 22. We have a sample deviation of 2 minutes. That is right here that I'm circling. Sample deviation 2. It gives us a confidence level. There's a lot of highlighting here, which is why I didn't want to highlight too much. It gets a little chaotic. We have a confidence level of 99%, so 0.99. Well, let's just go ahead and calculate our degree of freedom and then find our t-score right now. Let's just get it all out of the way. So remember, degree of freedom, n minus 1. So my n was my sample, 23. 23 minus 1 is 22. I need to find my alpha. Alpha was 1 minus your confidence level, which was 1 minus 0.99. I get 0.01. But I need my alpha divided by 2. That gives me 0.005. Okay? So I need to look this up in the table. I have a degree of freedom of 22. And then 0.005 is going to be right here. So I have a t-score of 2.819, all right? And that's what we wrote right here. It is very helpful just to get this out of the way early on because you're going to utilize this information to help you with your understanding here. So very similar to 9.1, we want to find our parameter here. Our our mu is going to equal to the population mean compute times for the workers in a city. So population mean compute times for the workers in the city. Okay. Our conditions here, we have to meet two. These should look very familiar to you. The conditions is the population normal? Well, we know that it told us at the top it's normal. If it doesn't meet that condition right away, then that's where you want to find if your n is greater than or equal to 30. Here, our n is actually less than 30, but that's fine because we already met the standard of a population being a normal distribution. So what that allows us to do is actually conduct the problem. So here we have a bunch of information. Again, this is very similar to 9.1. It's just a different formula in a way. The right-hand side is pretty much the same, but the left-hand side, before you had point estimate, but now this is your sample. So we have a 22 down here, plus or minus, and if you're confused where that 22 came from, let's go back up at the top real quick. That's right here. That is our sample mean, okay? So it's an estimate of sample, and then plus or minus, and then this calculation, the whole thing to the right is our margin of error. But if you remember that t-score up here, that's why we needed to calculate it, because we need it for this calculation. So 22 plus or minus our t-score, which we found within the table, divided by our sample deviation, divided by the square root of our sample, which gives us 22 plus or minus 1.176. You all are capable of doing that in your calculator. So we get our range right here, okay? Well, what's our conclusion here? Remember, for your conclusion, you want your wording to be very specific. So it'd be helpful to memorize how this wording is laid out. And as you can see, it's very similar to what we did in 9.1. We are 99% confident that the true population mean commute times for workers in a city is between 22.8 and 23.2. Now, before we rounded for our bottom part here, but I don't want to round because it's not exactly clear if I round, because you're basically saying 23 and then 23. It's not a clear showing of your range or your intervals. So I would recommend that if you're dealing with something that's kind of close and you see that if you would get 23, 23, just keep it as a decimal. That way it gives the reader a little bit more sense on the conclusion that is happening here. Okay, let's move on to another one. So here, we're going to do the same thing. We're going to write our givens up at top based on what example is being given in the information that's being shown. But it says, Dr. Lasso performs a study to determine how effective acupuncture is in relieving pain. He measures sensory rates for a random sample of 20 patients. Suppose the sensory rates are normally distributed with a sample mean of 9 and a sample standard deviation of 1.6. The confidence level is 90%. Perfect. That's all we're going to need for now. So my given, we have a sample of 20. And if you do your degree of freedom, as you can see, I'm cutting corners at this point. I'm not writing it all out for you. It was n minus 1, so 20 minus 1 gives me 19. My sample mean is 9. That was given, right? Sample mean 9. And then we have a sample standard deviation, S sub x, equals 1.6. We need to calculate our alpha. Our alpha was 1 minus our confidence level, which is 1 minus 90% or 0.9, gives us 0.10. But I need to find my alpha divided by 2, which will lead me to finding my z-score in a moment. So I have to find in the t-table or the table for my t-score 0.05 with a degree of freedom of 19. So I'm going to draw this way here. And then we have 0.05. And so I have a t-score of 1.729. Remember, that's going to be helpful for your calculation that you need to conduct. So my parameter here is population mean of sensory rates and relieving pain of acupuncture. Now, this is going to, the way that you write it is going to kind of be dependent per student because each student might have their own way of writing this out. But for the most part, you're going to want to have something very similar to what I have written here. And again, this can be found with what is being provided in here because we want to find mu. I know I want to find mu because it says literally find a 90% confidence interval estimate for population mean. Well, what is the population mean talking about when I find it? Well, it's talking about your sensory rates in relieving pain after acupuncture, and that's what's given up here at the top, okay? So it is extremely helpful to know what is going on with inside the problem, and that will supplement your understanding for finding the parameter. Just like we saw previously, you have two conditions that need to be met. It is the population being normally distributed. It has to tell you that. Remember, you can't make the assumption that it's normally distributed without it telling you that it's normally distributed. Or if it's not specifying it in the paragraph, then it has to meet the condition that our sample is greater than or equal to 30. And if you remember, that's the central limit theorem that was provided in prior units. So here it told us it was normally distributed. Perfect, we can move on. And then we have our calculation here. As you can see, I just copied and pasted what was provided in the notes right here. Our sample mean was 9. That was given inside the paragraph, plus or minus my calculation of my t-score. I found this in the table, right? We had to calculate alpha divided by 2. We had to look it up by looking at our degree of freedom as well as our alpha over 2, which gave us 1.729. I know my sample standard deviation is square root of my sample, which was 20, and we do the calculation there and we get our intervals or our range. So what is our conclusion then? Now, if you notice, the conclusion is very similar to what the mu is, and that should be the case. The reason why is because that's exactly what we're looking for. We're looking for a conclusion that is predicated on the population mean. So we know our confidence level is 90%. So what we can say here is we are 90% confident that the true population mean sensory rates in relieving pain after acupuncture is between 8.4 and 9.6. So again, all you need to do is remember how to write this. What you definitely need here is your 90% confident, or whatever the confidence level is stating that it's going to be. And then you also need to state that true population mean, and then your sensory rates in relieving pain after acupuncture is going to be predicated on the problem. So that's going to kind of switch out. And then you want is between, and then whatever the values are going to be. So pretty much we are blank confident that the true population mean blank is between blank and blank. So I kind of listed out a syntax for you. I would highly recommend that you have that in your notes. I don't think I'm going to create another worksheet again that just has the syntax available for you. Okay, moving on here. This is optional, but it's something you want in your notes because we could test on it or even quiz on it. So we're finding the sample size needed to estimate the population mean within a general given margin of error. So what we have here is determining the sample size n. I know this looks chaotic, but let's kind of walk through it here. So researchers would like to estimate the mean cholesterol level mu of a particular variety of monkey that is often used in laboratory experiments. They would like their estimate to be within 1 milligram per deciliter, mg over deciliter, of the true value of mu at a 95% confidence level. A previous study involving this variety of monkey suggests that the standard deviation of cholesterol level is 5 milligrams per deciliter. Obtaining monkeys is time-consuming and expensive, so the researchers want to know the minimum number of monkeys they need to generate a satisfactory estimate. Okay, so we know, and I'm just going to set this up for you, and then you could do kind of the calculation to find n yourself. We know what our E is, okay? E is 1. Right? It said they would like their estimation to be within 1 milligram per deciliter. Okay, so our E, it's kind of our margin of error. And then our alpha was 1 minus our confidence level. We've done that. Alpha divided by 2 is the same. And so what's happening here, and this is actually kind of unique for this problem and for just 9.2 in general, is you see your Z up here? This is your Z score. There is a connection that could be made to what we were utilizing for our Z-score and then our T-score, as well as your degrees of freedom and the kind of the normal distribution curve. But when we're trying to calculate our N, we're going to utilize Z-score. So when we find our alpha over 2 and we get 0.025, that's what we want to look up inside the table. And what we do is we get our Z of 1.96, okay, a Z-score of 1.96. And then our sample standard deviation was 5. So once we have that, we kind of have everything that we need here to basically plug and play and solve for our answer. So we have our z-score of 1.96. That's where we had to utilize table A from prior chapters. And then we have our sample standard deviation of 5. That was given. Okay, that was given. Over our margin of error, they wanted their estimation to be within 1 milligram per deciliter. So that was my E. I could have put ME. It's the same thing. Error, right? Margin of error. And that's going to be over 1 and then over 2. Or not over 2, but to the power of 2. And then you'd run that simple calculation and you would get your N. So I wanted to keep things short here and sweet for all of you. If you are confused, it is helpful to try and just do the problems over again, meaning just erase them and try to complete them on your own and then check your answer. Because you've only seen it one time and it's new, the odds are you're not going to memorize every little step, but it is helpful to pause the video and then kind of go through it again and check your work, check your answers. We'll have practice in class as well as extra practice for your quiz review and then your exam review. But that is the conclusion of 9.2, also unit 8.1, 8.2, 9.1, and 9.2. So congratulations on completing this unit, and I'll see all of you very soon. Thank you.